Good afternoon. And welcome. I'm Dave Ferguson, Dean of the College of Architecture and Planning, and happy to see you all here, and looking forward to this presentation. So we have, as usual, AIA and LACES credits, so the sign-up sheets are outside for those in the professions. And this presentation is part of a series of lectures and workshops to bring us all into a better understanding of generative AI's impact on society and on the field. So stay tuned for more events as we go through the year. And here to introduce our speaker tonight is Assistant Teaching Professor of Architecture, Zach Michiel.
Okay, well, I am blessed to be able to introduce our presenter tonight because he was one of the deans when I was in school. So I've worked with him, I've spoken to him a lot. Very excited that he's here. Tonight's presenter is Deputy Dean and Professor Adjunct at the Yale School of Architecture, where he was also a student, in his words, 1,000,000 years ago. He specializes in project delivery, social justice, and the integration of digital design tools into architectural education. He's been honored twice by Design Intelligence as one of the 30 most admired educators in architecture, and as a fellow of the American Institute of Architects. Before returning to Yale full-time, our lecturer was an associate principal at Cesar Pelli Associates, where he managed projects for the Mayo Clinic, Washington National Airport, and Goldman Sachs, as well as Vice President of Strategic Industry Relations at Autodesk, where he was responsible for setting the company's AEC vision and strategy for technology. His recent book, Machine Learning Architecture in the Age of Artificial Intelligence, was published by the Royal Institute of British Architects in 2022. Here to present his lecture entitled, Who is the Architect? Understanding Professional Agency in the Emergent Era of AI. Please give a warm cap welcome to Phil Bernstein.
Okay, thank you. Can you guys hear me all right? All right, so we're going to talk today about 3 sets of questions that are related to what we do as architects, how we relate as architects to other people in the systems of project delivery, and how technology might affect that question. What we're not going to do is demo software or look at startups, where I want to try to set a more philosophical approach to this question. So to give you a kind of different way of thinking about the problem. And as Zach mentioned, Ariba called me a couple years ago and asked me to write this AI book, and I hadn't really thought about AI all that much. But then I began thinking back to my history and realized that literally in another century, I, as an undergraduate architecture major, had taken an AI course. There was a guy at Yale where I was an undergrad named Roger Schenck, who was an assistant professor who had a theory about how you could write a computer program that could read a newspaper article. And my final project in his class was to write an article write a piece of software that read newspaper articles, like from the newspaper. You'd type them in, and then you had to ask questions about what happened. It was about oil tankers and oil spills. I got a B- on that assignment, because the professor or the TA wrote on my code, this is terrible. This code can't tell the difference between an oil tanker crash and an automobile crash. So it was kind of a semantic collapse there. We wrote our code on this machine, which was in the Yale Computer Science Department, called a PDP 1145. There were 10 or 11 of us that worked on this same machine. My iPhone has 1,000 times more memory than this machine, and one day while we were working in the lab, it literally exploded into flames. It blew up in a fireball, because we have a kind of a compute problem in architecture, but I'll get to that in a second. So I want to frame the discussion today in terms of 3 questions. The first question is from George Johnston, who is a professor of professional practice at Georgia Tech who does a lot of interesting work studying the evolution of how architects operate. And he's about to publish a paper, and he's done some interesting work on this question he calls, who is the architect? Who actually makes design decisions that manifest into a constructed building? The second question is a question that I ask my students in our courses about practice. How long does it take you to have a good idea? You're getting paid a fixed amount of money to have a good idea. How long does it take? And can you project that? And can you make it happen slower or faster? And then finally, a question posed by the Suskins, a father and son team that we'll describe later, who wrote a very interesting book called The Future of the Professions. And their question was, how do we solve problems to which architects are currently our best answer? So let's look at that from a couple of different perspectives. Now you got to go back historically to a really important moment for us as architects, which was when Alberti in the Renaissance invented our profession. And what Alberti did in his treatise, and this is directly from Mario Carpo's work, what Alberti did in his treatise, is, according to Mario, is declare that in a very Renaissance way, ideas and physical things were separate from one another. That there's one group of people called architects who have ideas, and another group of people called builders who execute those ideas. Now, Alberti also said that drawings should be perfect and the contractor should follow the drawings perfectly, but that's the subject of a different lecture, right? And so what Alberti did there at that moment was create this dynamic between idea generators and idea executors or builders, architects and contractors. And that dynamic of the relationship and the tension between that idea of the heroic designer and everybody else they're reliant on is a subtext for this whole conversation we're going to have about who is the architect. Because the question is, who's making the design decisions? So here's two quotes from Josh Ramus, who used to work for Rem Koolhaus and now has a practice in New York. It says, architecture is not created by individuals. The genius sketch is a myth. Architecture is made by a team of committed people who work together, and in fact, success usually has more to do with dumb determination than genius, which is why you people spend so much time in studio, right? That's dumb determination. Everybody wants to talk about authorship. It really is kind of irrelevant. Its only relevance is who makes the space for something to happen. So the question we're going to talk about philosophically here is, what makes the space for something to happen? How does something actually happen when you as an architect or an engineer or a construction manager, interior designer, planner, historicist are trying to make something happen? Now, George has been working on a project that I worked on to at least set up this thing that if you guys are not using this, you should, this thing called the Propel Library, which is a library of videos of experts in professional practice that you can use as a resource. And his question about who is the architect is investigated in a very interesting way in his video in the Propel Library, because he begins to examine this question by looking at the history of this document called the Handbook of Professional Practice, which is this kind of tome that architects use to catalog their best thinking about how architects should work. And ironically, I ended up writing the project delivery chapters in the 13th, 14th, and 15th editions of this book. But here, George is unpacking questions that are raised in the original document, which, if I'm not mistaken, was 1924, trying to understand the relationship between architectural activity as an art, as a science, and a business. But what he also looks at is the systems of delivery, where we arrive as architects in the relationship to everybody else that Josh is describing is necessary to deliver a project. And these are just a couple of diagrams that he uses showing the evolution in the American architecture profession, where the architect used to be operated as an agent of the owner and the drafters worked for the contractor. And then in the early 1900s, the contractors separated out as a separate discipline. And then we had general contractors, and there's a whole set of these models that we'll look at in a second. But George describes the question in a very interesting way. He describes the question as defining architecture as mediated agency and collective intelligence. In other words, redefining the roles of these players as things evolve and figuring out where the intelligence is to actually get a building designed and built. And so when you inject technology, and particularly artificial intelligence technology, into this set of relationships, you raise a bunch of super interesting questions, none of which I will answer today, but I'll at least raise them. And what we've done as a profession and as an industry, at least in the United States, is we have attempted to mediate agency and manage collective knowledge by creating different configurations of the primary players in the system. The client who wants the building, the architect who creates the design, or the designer who creates the design intent of the building, and the builder who executes the concept. And we've tried various relationships, construction managers, design, build. There's been all these different kinds of rearrangements. And what I'd like to suggest to you is that strategy of rearranging the pieces on the chessboard in a context where technology is beginning to take more and more potential authority is over. And that we may have come to the end of the evolution of fundamentally different project delivery paradigms in this construct. So when I wrote this book, I was really interested, the book is organized differently, but I'm really interested when it comes to trying to explore this AI question in 4 categories of exploration. What is the infrastructure that the design profession brings to this question? What stuff flows into that infrastructure to make the use of the technology possible? What might happen when those things flow in? And what does that mean the future of our, at least the architecture profession, might look like? So let's look at the infrastructure. So, I spent a lot of time as a vendor, right, because I work for Autodesk, and I spent a lot of time explaining to people how technology evolved. And I finally, after 16 years, came up with a diagram where I got the whole history of the evolution of technology and architecture down to one diagram. And this is it. It's all here in one diagram, right? Very simple. Several thousand years of drawing things on pieces of paper, which are super cheap, with pencils that are super cheap, but an excellent abstraction strategy, right? Because you can draw something complicated like a site or a building with something very uncomplicated using an abstraction strategy called plans, sections, elevations, and details. Very efficient. Then in the mid-1980s, when I was first starting my career as a practitioner, we started drawing things with computers. Same strategy, different pencil. Computer-aided drafting was essentially drafting brought to you by digital means. Then sometime around 2008, we asserted a representational paradigmatic shift to building information modeling. Instead of just using the computer to draw things, you made a model. The model was a database. The database had tons of information in it. The drawings are a report. You extract the drawings from the model. Then we're about to enter into, if we're not already there, an intermediate phase that I call the data interstice. And the data interstice is this moment that we're in where there are tons and tons of digital tools out there. Everybody's generating a lot of data. Like everything that happens in the building industry, it's completely disorganized, heterogeneous, unrelated, non-interoperable, and there's a lot of data out there that we don't know what to do with. And that we'll have to get through the data interstice until we get to an era where artificial intelligence is truly useful for us as a profession. And so if you read my book, there's more about ideas about precision and automation. But I want to draw a taxonomic distinction about the different kinds of technologies that are out there. And I think for purposes of this exploration of AI, and what I talked about in my book was there are really 3 kinds of software out there. Software type number 1 is what I'll call algorithmic software, which is like most of the stuff that you use. Excel, AutoCAD, Revit. It's a big code base. The computer starts at the top of the code stack and runs to the bottom of the code stack, unambiguously from top to bottom, right? The second type of technology that's out there, that's a machine learning or artificial intelligence technology, is what I call empiricist software, which is the stuff you're all using or thinking about right now. It's not code in the traditional sense. It's code that memorizes the statistical correlation of the relationship between pieces of data that it finds in the universe and figures out the probabilities that when one thing happens, something else is going to happen. It's a statistical model. It's not based on any rules. But what I learned from Professor Schenck back in the 1970s was that wasn't actually going to work. What was actually going to work was some more symbolic, or what I call cognitive software, that understands something about the way the world works. These empiricist systems, these large language models, these image generators that you're messing around with right now, these are purely empiricist models. They have no cognitive understanding of how the world works. They can't reason about it, and they do inference by statistical correlation. And the question I want you to be asking yourself as we finish this conversation today is, how far can you get as an architect or construction manager or interior designer using a tool that is trying to memorize the world? Not reason about the world, but memorize the world. And I think, in my view, you can only get so far. Now, one nice thing about what's happened with artificial intelligence is, in order to run it, you need the infrastructure of these enormous data centers, which we in the design and construction profession can't afford to have, right? We have access to them, we can design them, we can build them, but they're way too expensive for us to build ourselves. And so we are dependent on providers of infrastructure who have very little interest and no expertise in design or construction or asset operation. And those platform providers start out with the people that you're accustomed to, right? The Microsofts, the Metas, the Googles, the Alphabets, the Amazons of the world. They're like the super platform providers. And then they're what I call the sub-platform providers, who are the players who are large enough to begin to experiment with next generation platforms like Revit. This is Autodesk Forma, Trimble's got one. They're all the kind of building industry sub-platform providers that are experimenting with running their stuff on the big data centers, using the models that they incorporate from these other places, but making their own stuff. And then there's all the other crazy stuff that's going on out there. This is a website my students and I follow called AI in AEC. This guy catalogs every startup tool out there that does something related to artificial intelligence in the building industry. We started following this website in October of last year. It had about 300 companies on it. I checked it last night. It's at 1,700 and something. Now, he's not curating this. So if your marketing material says AI, you make it on his list. But nonetheless, you see there's a lot of activity happening at these various layers, and none of it's particularly organized because we're in an explosive innovation moment right now where there's nothing clear happening in terms of direction. And then finally, I want to make a comment about the intellectual infrastructure of the building industry. So on the left is a list of industry organizations associated with design, construction, and building operation in the United States, generated by Perplexity this weekend. It's like 20 of them, right? In the middle, the National Institute of Building Sciences with the BIM standard and the CAD standard. How many of the students in this room are aware that there's a national BIM standard or a national CAD standard? Okay, I make my point, right? The efficacy of these efforts is very limited. And then, of course, our friends from Building Smart, who've been trying for the last 40 years to create some kind of data interoperability standard and largely have not been able to succeed. So we're dependent on other people's infrastructure, and we don't really have the intellectual throw weight to get ourselves organized around this problem of the data interstice, where there's all this data kind of flowing around. Okay, so there are your platforms. Let's talk about the inputs. One of the things we never talk about when we're razzing ChatGPT is how much energy and water these things use. They use enormous amounts of energy. And in order to keep them cool, they use enormous amounts of fresh water. And they use enormous amounts of rare minerals that are extracted by enslaved people in places that you've never heard of. So there's a lot of physical, technological infrastructure upon which this whole proposition is dependent that is not ultimately going to be reliable. We were just talking over lunch today that apparently Microsoft recently decided to buy the decommissioned nuclear power plant in Pennsylvania called 3 Mile Island because they need the electricity. So it's a software company buying a nuclear power plant. Who feels good about that idea? I mean, I used to work for a software company, and I think that's a terrible idea. So you've got this big question about how we're actually going to run these things. Meanwhile, there's all this technological frothing going on. There's all all these tools generating all kinds of stuff. This is some work I did based on how my friend Jesse Devitt, who's a venture capitalist in the building industry space, these are all the different kinds of technologies that generate data that he tracks. Modelers, computer vision, electric vehicles, Internet of Things. There's all this stuff happening, right? And if we're going to make sense of this whole idea of artificial intelligence, we have to make sense of all the data that are the inputs to the artificial intelligence. So one of the ways I tried to structure that thinking, at least in my writing, was to say, okay, look, as designers and builders, we generate all the stuff in the green box. We make models, we capture information from reality scans. Our engineers do things like evaluation and simulation. Our construction teams generate all kinds of data. Our buildings generate all kinds of data. It all lives in these kind of amorphous pools. And if we're going to be able to use it in an intelligent way as an input, two things have to happen. One, we got to figure out some place to put it in a common location, which doesn't exist. And then we have to use intelligent application of artificial intelligence, not just to process it, but to actually organize it. But if we can do that, maybe nirvana is the stuff in the pink boxes, right? We can automate the generation of design alternatives. We can use the AIs to evaluate the alternatives that we're generating. We can automate things on the construction site. We can make buildings operate in an autonomous way. This is a kind of super nerdy, if life really worked well, flow chart of how the before could become the after. But right now, we have no chance of making that happen, given the infrastructure of the industry. Now, another way to think about this is I know some of you have read Mario Carpo's work, what Mario talked about in his last book, where he says, computers can deal with the most overwhelming, meaningless mess. Think of the typical Amazon warehouse due to their sheer memory, speed, and processing power. Great. That sounds great, because what we operate in is a overwhelming, meaningless mess of data that's getting bigger and bigger. But the problem is not technical. The problem has to do with our ability as an industry to deal with it. And a couple of years ago, I worked on a project delivery study, where I flew around the world and I looked at how different project delivery models were working. And I'm not going to take you through this thing in detail, but basically what we talked about with almost all these industry players was this idea that the industry itself doesn't work very well. It's inefficient, it's siloed, it's risky, and we'd all like to live in a much more trusted nirvana where we were working together and outcomes were more predictable. And there's a whole bunch of stuff that we did. I did a whole bunch of analysis to get to this. But what we talked about was this idea that the building industry has what we called transactional incompatibility. It's the data interstice. Everybody's making their own stuff, and their stuff doesn't play with anybody else's stuff, right? Does the contractor use your Revit model? The construction management students are supposed to scream, no, it sucks, right? That there's all this information out there that doesn't pass from silo to silo, and what we really want to be is in this place where people trust their data, but it's not a computer science problem. It's a structural problem in the way the building industry actually works. So we don't have terrific infrastructure to figure this out, and we end up creating all this data that's largely unrelated to itself and to others. And just to demonstrate that, I want to show you this diagram. So this is the diagram that I use with my students to explain all the ways the architect talks to the contractor during construction. Don't try to make sense out of it, because they can't either, right? This is just construction, right? So now the proposition here is we're going to take this giant morass of untrustable data, and then we're going to add artificial intelligence to it, and somehow everything's going to work out. But when you begin to actually look at the challenges of artificial intelligence sort of structurally, you start asking yourself, are these tools reliable enough to do the hard things that we do as architects and engineers and construction managers, interior designers, planners, and historic preservationists? Is it reliable enough? There's a whole list of things here, a whole list of questions that we should be asking ourselves. And this is my favorite tennis player. This is Roger Federer, right? Roger Federer gave a great talk at Dartmouth for commencement this summer where he said, I won more tennis matches than almost anybody in the history of the game, and I only won 54% of the points that I played. 54%. Now, 54% may make you a world champion tennis player. It is, in terms of the professional standard of care, it's not so good, right, Troy? I assume you guys are running your practice at a level of precision higher than 54%. And so what you don't hear in the dialogue is whether or not these systems can evolve in a way that they can be much more reliable and we can begin to depend on them as professionals. This is the Stanford AI report, which just came out last December with a very interesting comprehensive survey of lots of different things that are happening in AI. And this is what they said. Current AI technology still has significant problems. It cannot reliably deal with facts, perform complex reasoning, or explain its conclusions. That's what I trained to do as an architect. Deal with facts, perform complex reasoning, and explain my conclusions. That's what I did as an architect, and that's what you're training to do as designers and construction industry professionals. So there is a big disconnect between the current capabilities of the technology, our ability to marshal the necessary infrastructure, and getting to a point where we can do more than generate provocative text and sexy images. And I think we need to think about that in a different kind of way. Now, one strategy to think about that in terms of technology's capabilities is to think about how algorithms have to become increasingly capable to get to a point of greater reliability. So in my book, I worked with a computer scientist named Mark Graves, who's is a AI expert, and we talked about changing Bloom's taxonomy of learning. The teachers in the room are aware of this, right? You start at the bottom of the taxonomy, you get your students to remember things, and if you're really good and you take them through the steps, at the very top of the taxonomy they can create things, right? Some of the instructors in the room are smiling. And so we refactored that into an AI taxonomy, where we said, okay, first thing these tools have to do is understand what's going on, then they can evaluate things in context, then they can make a simulation so they can reason more accurately, and then they can create. And the current technologies skip through all of that and go straight to create by memorizing things, right? So one of the ways to think about this is maybe what happens is we start with technologies that are about analysis, then we move to technologies that based on that analysis can predict things. And then once we're predicting things, we can do provocations. We can do image generation and other kinds of stuff in a more reliable way, in a way that is better than Roger Federer's 54%. So ultimately, we might get to the point where these technologies can do something that is related to what we call design. And in a separate discussion, we can talk about how that idea is correlated to this idea that we're eventually computationally going to get to artificial generalized intelligence, which I don't buy, not for 1 minute. I do not think in my lifetime, which is shorter than your lifetimes, that we're going to see generalized artificial intelligence anytime soon. So what does that mean about what we should be doing as scholars, as students, and as practitioners to make some sense out of all this stuff? And I think we talked about this morning, or this afternoon over lunch. Architects tend to use technology, especially architects, tend to use any new technology to make images and shapes. That's what we tend to do. Anything, right? AutoCAD comes out, curvy buildings. Project Maya came out from the game makers, blobby buildings. AI comes out, we're trying to make super erotic renderings. We're not deploying the technology in a way that in my view, is best for us as agents in the building industry. And so what I'd like to suggest is that we think about 5 potential technological strategies for how we want to move this thing forward, and that these strategies might be an agenda for the building industry, and particularly for the design professions. Number 1, we got to get on top of our data. And in my book, I talked about this idea of trying to force a discussion about a place where the building industry could put its data in a common location so that data can be used to train intelligent machine learning algorithms. Because right now, it's just trained on whatever crap it can find on the internet. Secondly, and this is happening all over the place already, is around production, right? Troy, I assume you guys are, and we talked about this briefly, your marketing department is doing stuff, you've got a help desk. These are important but low risk propositions. internal to your practice proposition, which is normal because we're always looking for efficiency strategies. Then we could also, in a disciplined way, use the technologies for what I call provocation, which is, I hadn't thought of that idea. This algorithm is looking at things in a different way. This image is making me think about things in a different way. But I find that to be the least interesting opportunity, because where it really starts to get interesting is around analysis, like can I reason about this design, and forecasting. Can I predict what this design is going to do? Because that's what my clients want. My clients want me to tell them how my design is going to work. That's the business that we're in. As designers, we forecast a future state and we instantiate a spatial solution around a future state. That's what we do. So in my book, I kind of organized a taxonomy of different ways that you can think about the architectural proposition and different kinds of solutions around and goals and solutions that might work, and you can look at that if you're interested in it. But a much more interesting book is this book by the Suskins. And what the Suskins talk about in this book called The Future of the Professions is they believe that the fundamental idea of professionalism, like why society has professionals, is going to be under attack because of artificial intelligence. And this is the second edition, which if you're going to buy it or read it, I would urge you to do, because they wrote it first in 2014, then they went through COVID, then they issued a second edition where they basically said, we were completely right in 2014. I don't agree with everything they said, and I think their section on architects is particularly weak, but that's neither here nor there. What they talk about essentially, what they argue is that the professions do things that artificial intelligence will dismantle. We hoard knowledge, and we have process expertise. And that tasks, not jobs, but tasks will be systematically consumed by these algorithms. And the second dimension of their argument is around this question of innovation, how the professions might innovate. And what they say is there are two kinds of innovators in the professional world. First-gen innovators who are just about efficiency, right, which is what you guys are doing right now. And then second-generation innovators who actually try to disrupt the system. And that's the argument I want to make. I'll stipulate that everybody's going to be a first-gen innovator. We got to get to the second-gen innovators because they're the ones in search of credible, promising alternatives to the sale of the human time of experts. Credible alternatives to the sale of time of human experts. And for the designers in the room, that's how we get paid. We sell time. We sell time and we try to avoid risk. And maybe there's a strategy, maybe there's a value proposition strategy based on this technology that lets you look at the problem in a different way. One of the ways I argue about this with my students is risk, which is something that the building industry likes to avoid, is actually a value proposition strategy. That if you, assuming risk with the help of technology might be a way to get away from the tyranny of selling time for money. And what I talk about is this idea that there are three risk strategies: mitigation, management, and then embracing risk. And there's a whole progression of things that we could do in the building industry that include assuming more risk and therefore potentially creating more reward if we deploy some of these technologies in the service of doing all these things. And I can see Troy's head's about to explode over here. But the problem is the standard of care, which is what we do, is this pink zone at the bottom here, right? We stay out of the risk zone. We don't assume additional risk. And so we don't gain the value. And so sort of taxonomically, maybe the strategy here is to use, instead of using these technologies to make shapes and images, maybe the strategy here is to use the technology to make things happen, predict how the world is going to work, and then change our business models so our business models are about outcomes and not about selling time for money. And I built this argument that says the lowest level outcomes are transactional, like being efficient, but the highest level outcomes are aspirational, like why do our clients build buildings? To do stuff. What if we promised that the buildings that we design for them are actually going to do things, and when they do things, we get paid for it? I'm not selling time. It doesn't matter how much time I take. My building does the thing I said it was going to do. I'm going to get paid for it. Of course, there's an inverse relationship to risk there. But one of the ways to look at this is that there's a kind of taxonomy of this that's dependent on the relationship between the designers and everybody else. That at the very lowest end of this outcome idea is what I call transactional outcomes, which is like doing the normal job better, right? And we can do that by ourselves. We can use the technology to do that by ourselves. If we involve our builder colleagues, we can do things that our clients care about, like conform to budgets, conform to schedules, conform to specifications. But clients do not build buildings to do these things. Clients build buildings to save money or operate more efficiently. Or maybe what clients do is build buildings to do things like make money or make their employees happier or make their patients healthier or make the list of whatever aspiration you can think of that a client comes to you to design a building for. And if we can deploy the technologies in the service of this kind of analysis and prediction, I think it's a more promising avenue than making sexy renderings and having ChatGPT write your term papers. It just doesn't seem like a very interesting, seems like a cul-de-sac to me and a missed opportunity in this question of where we're going as a profession. So let's go back to our 3 questions here about who we are and how long it takes to have an idea and what problems, how do we solve problems to which architects are currently the best answer? And you can see now why the Suskins formulated the question in that form. The world doesn't need architects or interior designers or doctors or lawyers. What the world needs is health and spatial solutions and so forth. We are just instruments of that. So as professionals, we have to stay relevant around this question. And the way George has looked at this, and I strongly, strongly recommend for at least the architects in the room that you look at George's book called Assembling the Architect, because he looks at this question of what architects do through the lens of what choices we made about our relationship to the systems of delivery. And he does so through a critique of this kind of tongue-in-cheek book that an architect in the 1930s wrote called The Adventures of Tom Thumbtack Architect. And it's got it's just fun. I just read it, it's fun, right? So what George talks about, and it's very much tied to what the Suskins talk about, is this idea that the Suskins describe as the grand bargain. And if you're in this room to become a licensed professional, you need to understand what the grand bargain is. By the way, this is Benjamin Latrobe, the first practicing architect in the United States. And the grand bargain says, we, society, place our trust in the professions in granting them exclusivity over a wide range of socially significant services, paying them a fair wage, that's a different discussion, conferring on them independence, autonomy, rights of self-determination, and respect and status. That's why I became an architect, and I'm sure many of you feel the same way. The respect, the status, and the fair wage. That's a whole other discussion. But what these guys say ultimately in this book is, we argue that professions will undergo 2 parallel sets of changes. The first, dominated by automation, traditional ways of working will be streamlined and optimized through the application of technology. The second will be dominated by innovation. Increasingly capable systems will transform the work of professionals, giving birth to new ways of sharing practical expertise. In the long run, this second future will prevail, and our professions will be dismantled incrementally. Now, if I thought that was true, I would not have the job that I have today. And if you thought that was true, you wouldn't be in this room right now, right? What I do think is true is we should think very deeply about what it means to do the things that we're doing and how we can strategize around these technologies and how they're going to evolve. And one of the ways to think about that is, this is Victoria Beach, who used to teach pro-prac at Harvard a few years ago. She said, expecting an architect to design a safe structure, which is why we have licensure, right, is like expecting a chef to cook a safe meal. It is both a high ethical requirement and a very low expectation. And one of the things you see a lot of AI activity around is code compliance. Once artificial intelligence can do your code checking, you need a different reason to be an architect. So I think we need to start thinking about those reasons. And if we think about those reasons instead of by virtue of tasks, but if we think about them in terms of what roles we play in the systems of delivery, that'll give us a strategy for how to think about this stuff. So the way I describe this to my students, which is in this diagram, is architects essentially play 4 roles. Number 1, we protect the public's health and safety. That's why we have licenses. Number 2, we act as agents of the client. We translate their desires into a spatial strategy. Number 3, and I use this word carefully, we guide the builders to build the things that we have designed. I'll leave that at that. And 4, we run the teams that allow us to make all that stuff happen. Those are 4 roles, pretty hard to write an AI to take care of, right? Those are all about relationships, judgment, making ambiguous decisions, synthesizing incomplete information, and using a design brain to make a complicated thing like a design happen. And so I think if you think about the problem through that lens, it's very hard to argue that our profession is going to be completely dismantled. But if we continue to think about it in terms of traditional project delivery structures, like the diagrams I've been showing you, we're going to get dismantled in a different kind of way. And then what we have to start thinking about is what it means to make a design happen. Lots of different ways to do that. This is Zach. This is Paulo Tombesi. The whole flexible specialization theory. Paulo's idea is that you take the idea of designing and turn it inside out. So building design is a whole array of things that architects have to do. And what we have to do, at least in my view, is avoid the danger of this image, right? So on the left, I bring you, ladies and gentlemen, a kick-ass building information model from 2008, a hospital being constructed by DPR in California. And you look at that model and you think, man, those guys, that thing is completely worked out, right? They've modeled everything within an inch of its life. That's so much data that could be used in so many interesting ways. But what we have done with the tools that have been given to us, the new tools, like BIM, is this thing on the right. That's a working drawing. It's just another working drawing. It's faster, it's more accurate, it's better coordinated. So we took the CAD world and we made working drawings. Then we took the BIM world and we made working drawings. If we take the AI world and let it make working drawings, we're going to be dismembered. We're going to be dismantled. And we have to think about it in a different kind of way. In fact, one of the studies I did in my book was comparing the different project sequencing of different countries and trying to assess how much of the work could be automated by an AI. And it turns out quite a bit. It turns out somewhere between 40 and 60% of the production work of the standard architect's practice could be attacked by an artificial intelligence algorithm. So what do? We either have 60% fewer of you, because we're not going to need you anymore, or we have a different strategy. We're going to need a different strategy. And we're going to need a different strategy, not just for how to deploy technology or how to talk to our clients. We're going to need a different certification strategy and a different educational strategy. We're going to need to think pedagogically about the problem in a different way. We're going to have to define licensure in a different kind of way. And those intransigent organizations that I showed you earlier are going to have to be a lot lighter on their feet. And so I think the academy, the practice world right now is in a mode of first generation innovation, and that's fine around efficiency. But the academy, places like this and where I am, are the ones that have to think through this problem in a more fundamental way. Just briefly, at Yale, I was on the Provost's AI task force, where we spent an entire semester just seeing what was going on the campus and creating a strategy for providing tools. And then on the right here is the diagram that we're using to teach an AI course, a sort of super AI course next semester to our students, where we're actually going to start inside out. We're going to start hands-on on the tools, and then go sort of larger about why these tools work the way they work, and then eventually get to looking at the impact for the discipline, and then eventually the impact for society. So we're going to take a very inside-out view of the problem to try to get our hands dirty around this question. And Zach, we're trying to design this course so you can get Viz credit, theory credit, or technology and practice credit. So it's either going to be great or a disaster, right? So if clients want spatial solutions to problems, what is the answer, right? And so just quickly, what we've done in the past is we've created project delivery paradigms to address the issues of the day. And I'm not going to spend a lot of time with this diagram, but my argument has always been that project delivery strategies like design build or construction management evolve in sequence with technology and with extramural socioeconomic conditions. The problem is we've run out the string, right? We got to IPD, which was the last big idea, and now we're at this moment of machine learning, and it's not entirely clear where to go from here. And in fact, I thought it would be fun. I asked Microsoft Copilot to draw me some IPD diagrams, and I got this kind of hot mess. It's not English, but I thought it would be fun. But my point is, these previous strategies don't address the issues that we need to face as a design profession. The issues we need to face as design profession are much bigger, like public safety. This was the fire at Grenfell in London a few years ago. The housing shortage, social equity, the enslavement in the building supply chain. There are a bunch of these much larger questions that we should be looking at and not trying to solve them by deploying these next generation technologies in the service of making images or writing paragraphs. And so I want to offer you two strategies in conclusion, a technological strategy and then a professional strategy. So technologically, so here's our architect, right? She's working at her desk. This is an AI-generated image, and the way you can tell is there's a compass on her desk, because architects use compasses, right? Not that kind of compass. For those of you who don't know what a compass is, it's a thing that we used to use to draw circles when we were drawing things by hand. The old guys in the audience are laughing, right? So she comes to the table with her education, her experience, and whatever reference materials she can marshal, and she has a job. And according to the Suskins, she applies a series of skills to do that job, and that series of skills involves a bunch of tasks. And those tasks will selectively be automated as machine learning algorithms begin to evolve. The problem in our industry is that right now, all the infrastructure in the industry is built on all the crap on the internet that has very little to do with the built environment. So it's hard for it to be relevant right now. And so what that means is we're still in a realm right now where we're using more general purpose AI tools, and they don't have a lot of the kind of traction that I'm describing here. But what we could do, if we wanted to, is say, okay, what if we decided as an industry and a discipline which of these tasks we thought were most important to apply these technologies to, and begin building tools around and data sets around those specific tasks. And I can think of 20 of them, and there's 20 more in my book. But questions of sustainable analysis, the understanding the supply chain, cost estimating. The building industry is terrible at costs, right? No matter, depending on whose stuff you read, somewhere between 30 and 90% of all projects constructed in the world blow their budgets or their schedules. That seems like an unbelievably unsexy, incredibly important opportunity for us, right? And so if we did that, we could begin to build an infrastructure of general AEC data from which we could begin to build specific AIs associated with the tasks that we choose, after which we might get to a more general purpose AI platform and have the AI that we want, not the AI that we're inheriting from these other players who know nothing about the building industry. And so, and then if our other disciplines, if the construction managers and the interior designers did the same thing, eventually we'd have this kind of superset of solutions that we could use. But we have to be strategic about it. So I'll conclude with a couple of points from that conclusion of my book, and this is specifically for architects. So this is more of a professional strategy idea here. 5 things, in my view, have to happen. Number 1, we need to choose the technologies that we think are important to the future of practice. Take it from me, I used to be a vendor. The software companies will follow the shortest route to profit, and that route may not be in our interest. Number 2, we need to start talking about performance. We need to start talking about outcomes as a specific characteristic of our roles, making things happen and proving that those things are going to happen using the technology. Number 3, we need to be very intentional about the infrastructure that we need that will form the platforms of design. That's the previous slide. Number 4, and I think this is incredibly important, the current disassociated, siloed relationship between design, construction, and asset operation will not get us to the place we need to be. Nobody has enough data, and nobody has enough horsepower to move things forward. We have to remediate that relationship. And if we can do those 4 things, then we can make this value proposition shift that I'm talking about. We can change the fundamental nature of the way designers operate in the system. But we should be deploying these technologies in the service of making that happen. And I think that is really the mission that both the vendors and the academy, along with our industry partners, should try to undertake. So with that, I guess we have, 10 minutes for questions? Thank you.